Welcome to Kocaeli and also welcome to Kocaeli University. Today we'll have the James Mitchell 4th Protein Calorie Restriction Workshop in our university, Kocaeli University. First, we want you to watch a small introduction video of our university.
Medical science, which focuses on human life and human survival, is one of the deepest rooted areas of expertise in history. Our country and our culture, which we originate from, have passed on to us the culture of medicine distilled from an ancient tradition that's achieved the most successful applications of the science throughout history. Today, Kocaeli University Faculty of Medicine and Research and Application Hospital, which has undertaken the task of keeping this culture alive and carrying it forward with the most modern conditions, is in the position of the apple of the eye of our university, our city, our region, and our country. Since the year 1992, when it was established, Kocaeli University Faculty of Medicine has been providing education in order to ensure that every student it trains within the understanding of its tradition is qualified physicians whose priority in the future is to serve their patients under all circumstances and who have the responsibilities of their profession. In our education services, which are constantly updated in accordance with the requirements of the modern age and constantly renewing itself in the light of scientific developments, in addition to training competent physicians in their field, research that contributes to science at the universal level are combined with qualified health services in line with the principles of good medicine. The facilities where Kocaeli University Faculty of Medicine carries out its activities are one of the few facilities in the region and Turkey with a closed area of 103,000 square meters where education, research and health services are integrated. The education block, consisting of lecture halls, classrooms, multidisciplinary laboratories and practice areas, library, free study areas, recreational and social areas to meet contemporary medical education, is intertwined with a research hospital with 772 beds established with high-end technology. In our faculty, which carries out education and research activities in 3 divisions, namely Basic Medical Sciences, Internal Medical Sciences and Surgical Medical Sciences, and 41 departments and 27 branches of science affiliated to these divisions, our faculty members who are competent in their field and make a difference with their national and international achievements successfully manage the educational processes of our students according to their interests and needs. In our faculty, which attaches special importance to internationalization and accreditation in education in its educational mission, the way for our students to meet different disciplines and gain experience is paved with bilateral agreements, primarily including Erasmus. Our faculty, which is a National Medical Education Accreditation Certificate, is becoming one of the distinguished medical schools in Turkey by combining all these studies with the education it provides. In education services, where a perspective that considers the demands and listens to the voice of the students with a student-centered approach is adopted, an application-oriented training program that strengthens clinical skills and combines theory with practice is carried out. This training is also supported by social medicine and ethics programs and is strengthened by studies such as problem-based learning practices, preparation for medicine program, and voluntary summer internships. Our faculty is proud to always be with its students in the challenging medical education with its social facilities that our students may need in Umuttepe, the main campus of Kocaeli University, which is growing day by day with its student-oriented education services that continue its activities with the slogan, "We learn, research, and produce together." With its contemporary, scientific, and constantly updated education approach and facilities, Kocaeli University Faculty of Medicine has adopted the principle of working with all its strength to train the physicians our country needs and be a brand in the field of science. We know the importance of medical education, and we work for our students and our country.
Now I would like to invite you, our Dean of Kocaeli University Faculty of Medicine, Professor Alparslan Kuş, please.
Öncelikle günaydın herkese. Sayın Rektörüm, Sayın Hocalarım hoş geldiniz. İzniniz verirse birkaç kelime İngilizce konuşmak istiyorum. Dear guests, welcome to our country or city, first of all. We are happy on behalf of our faculty to host the fourth Protein Calorie Restriction Workshop. I want to thank especially of our rector, Professor Dr. Zafer Cantürk, and our graduate Furkan Burak, and everyone who contributed to realization this workshop. I wish the workshop to be successful. Thank you.
Now I would like to invite you, Furkan Burak from Harvard Medical School, please.
Herkese günaydın. İnsanın evinde olması çok güzel bir duygu. Herkese merhabalar. Tanıdık yüzleri hiç yaşlanmamış ve gençleşmiş olarak görmek daha da mutlu edici. Zafer Hocam, Alparslan Hocam, değerli hocalarım, bizlere ev sahipliği yaptığınız için çok teşekkür ederiz. So from here I will continue in English. So it's a great honor to be here. So this is my home. So it's really a very interesting feeling to be back here, where I was sitting there and learning for all the years. It's all about human, what is medicine, and I was saying I'm going to be a doctor when I grow up, when I was there. So I'm still trying to be, but partly I achieved some. And then for those of you I'll introduce why we are doing this. And so this is an international working group, and thank you so much for all our speakers to come here. And last year we did this meeting in at Harvard, and then the year before we did in Leiden. And we're very happy to be in Kocaeli this year. I think this is going to be a great scientific festivities. So this group is basically studying the effects of calorie restriction on many different parts of life. Somebody's working on surgery, surgical complications, somebody's working on aging, somebody wants to live longer with some sort of an intervention, so this is going to be one of them. So the whole day we will discuss the different aspects of it, and I'm really happy that Kocaeli is part of it, because with this working group, at the end of the day, the whole purpose is to exchange the ideas and then move forward to the human. So to do the trials, there are already ongoing human trials that we really want you to contribute. You're not just listening, so you're part of it. So please contribute it. So please interact with our speakers. If you have an idea, or if you want to really move forward with some of the studies that you think that you can join, just let us know. Thank you. Okay. İsterseniz siz sunucu. Okay. So basically, I'll make the introduction and then I will introduce Zafer Canturk and we'll start the first session. So I'll make the introduction to just briefly to mention and conceptualize what we're doing. And it's all started with Jay Mitchell, and he was such an incredible colleague, and this is all started with him, with our colleagues. And so Kocaeli has a kind of a program with Harvard, exchange program, and Professor Jay Mitchell was the faculty coordinator of that program and really touched many of our lives. And he started this, and I learned the genuine interest of science from him. So he was calling me with a great excitement and say, Furkan, we fasted the mice for 3 days and did the surgery and we decreased the complications 300%. So let's go celebrate. So it was come from hospital, so I was going to the cafe with him, and then this Umberto that he was calling Mr. Figure One. And then for all these years, we created lots of figure ones and spread that out. And hopefully, we will complete the stories that started with him. And unfortunately, he passed away a couple of years ago, where he really wanted to do this meeting here in 2020. And he came to here, he met with many of you. He was so excited and happy to do this here. And I really believe that he's with us today. And we will honor his memory moving forward with these meetings. So I'm very, very thankful to Jay. So, and I will give you the introduction of it. And our group, I'm endocrinologist and working in metabolism. So we are looking for the immunometabolic aspect of caloric restriction. And so we basically focus on obesity. And unfortunately, it became a new normal. So this is 75% of the entire US is either overweight or obese. And we are not showing all these fancy maps anymore because it became like a new normal. And what happens is it starts with caloric excess, right? With the caloric excess, it really contributes to many different diseases. It's more than 100 or 200, everybody just add that up. But from like diabetes to atherosclerosis to asthma and many different things, even a cancer. So what happens is, with this caloric excess being continuous, it causes a chronic low-grade inflammation, and then it increases the reactive oxygen species production, and that causes more oxidative damage and stress. And then it decreases the antioxidants, which means like your antioxidant defense goes down because it's exhausted by all this process, and then your stress resistance is really messed up. So at the end of the day, all these processes, generally, we call it causes a deconditioning. So from your healthy self, you're in a really tough situation that you're dealing with this caloric excess. And then, so you become susceptible to a severe damage from an acute stress. And this can be anything. This can be surgery, this can be radiotherapy, this can be infection, drug toxicity, trauma, emotional stress, anything. So this caloric excess and obesity really decondition you to put in a very tough situation, whatever the second hit, so you get the damage. And we work on this in immune cell metabolism because immune cells are creating all these reactive oxygen species and really reprogramming in a wrong way. But in caloric restriction, basically it reverses the situation. So it does totally the other way around. It decreases the inflammation. It's an anti-inflammatory process. It decreases the reactive oxygen production, and then oxidative damage goes down, and it increases your stress resistance. Basically, you have more antioxidants around, so we call it reconditioning. So that actually you're protected from severe damage when you get that acute stress. If you get the surgery, you're more like you're ready to deal with it, or chemotherapy. I'll show you all the aspects. And so this group is working, again, whatever that acute stress is, or the chronic stress with aging, that's what we are working on it. And the whole idea is really nutrient access goes all the way to obesity versus caloric restriction, and it's affecting many different pathways. I'm not going to get into the details. So this is going to be more like introduction, but it's really minimizing the anabolic process. It favors maintenance and repair systems. It decreases the DNA damage. It enhances your stress resistance and then clear up all these damaged molecules. And it's more stimulating mitochondrial biogenesis. So all this process is just restore you. You know, this cleansing idea when you fast or there are special regimens. So it puts you in a more of advantage position. And then of course, the ultimate goal, not my goal, but most of the people want to live longer. And all of the animal studies showing if you do calorie restriction, you live longer. But really the main question is, does it really reflect to humans? Are we going to live longer if we eat less or restrict our calories? Or this group really specify, it's not just calories, this is the calories coming from protein and certain amino acids changing to some gas and everything. So you will listen all of those. But the whole idea in human, we're still wondering, but there are some examples of it, like Okinawans in Japan. For example, they live with 20% less calories, and they live average 5 years longer than the mainland Japan. And then this biosphere experiment was also put the calorie restriction into the idea that it was unintentional. So there was like a habitat, there was like a place that they got in, they need to do lots of research, non-medical, but they calculated the food wrong. They took less food with them, but they couldn't get out. And basically, for 2 years, they did a calorie restriction, and all of the teams really rejuvenated. So all of their kind of metabolic parameters improved, their cholesterol, blood pressure, so their diabetes went away, all kind of things, so that it really brought this idea, and it actually kind of created a group, they call it cronies. It's like a calorie restriction with an optimal nutrition, and they think you need to get nutrient-dense eating, but it should be calorie restricted. So they try to make it to 20 to 25% calorie restriction, which is not easy for humans, but they're almost take this as a religion, and we'll see how much they will live. So this is going to be the ongoing study that we will understand. Is it really going to reflect to living longer? And then there are other studies that showing, so when you do calorie restriction in long term, again, so your blood pressure improves, your glycemic control improves, your diabetes, if you have it, it improves, your inflammation goes down, systemic parameters, high sensitive CRP, all of the parameters that is leading to this aging process goes down. So we are hoping that it would reflect back to it. And of course, it's not easy to do calorie restriction in human. In mice, we just fast them with 50%, we create miracles, but it doesn't mean anything. As human, it's an evolutionary threat to the brain. So when you restrict the calories, so it's against your survival, the brain makes everything to gain it back. It gives you craving, asharme, it decreases your metabolic rate, so you burn less calories when you move it the same. So because of that, there are lots of innovation around this, and there are not many differences, even if you do daily calorie restriction, full day fasting, 5 day eating everything, 2 days fasting, 5+2, time restricted eating, whatever you can do, at the end of the day, it really reflects a good metabolic improvement. And then it's, again, I'm not going to get into detail, but it really gets into these metabolic pathways where some of the sensors like AMP or increasing the NAD pool and decreasing the IGF signaling and such. And then again in human, when you do this calorie restriction, so you really activate those pathways and decrease the inflammation. And I like this one, for example, they look at for example, cancer treatment, and even a cancer patient gonna get the chemotherapy, which is toxic, if you give calorie restriction before the chemotherapy, so their side effects are much lower, or radiotherapy as well, and they kind of simulate it here, which I really like to kind of conceptualize what happens. So before the treatment, if you do the fasting or calorie restriction, your reactive oxygen species, which is really damaging or activating. Reactive oxygen species is not just there. It can activate all these T cells, it changes things in your inflammatory tone and cause a damage rather than a repair. Because inflammation is a very fine tune. It can repair what is wrong, or if it's too much, it can damage. So if you do this calorie restriction, when you get the toxic therapy, of course it affects you, but it kind of stay in a more manageable place that you have more repair, versus if you don't do it, it really push all the way up, which it cause more damage. So this is a simulation and really nice research, but I just wanted to show and conceptualize. And then in the immune cell or infection protection, this is the same. So when you have a calorie restriction, it really boosts your immune system through like the T cell, and even from antigen presenting cells, which starts, you become more tolerogenic if it's basically autoimmunity or metabolic disease, or if you have infection, you have basically more soldiers to fight. So I would like to stop here so that, you know, it is not easy. Everybody talks about calorie restriction fasting and why we are not still living longer, because it's against our creation. So we are trying to find how we can mimic this physiology. Are we going to find some mimetics? Are we going to apply for certain aspects? Are we going to create certain miracle shake that it has this amino acid but not that one, this fat but not this one? So we'll try to find what are the macronutrients that we can really combine and then have as a optimal nutrition. So that's what we try to do with this all efforts. And again, so I'm very thankful to Kocaeli Medical School and all of you will discuss and today on all about this calorie restriction. And I think I can get, if there's somebody has any questions, I can answer. But it's great to be here, and thank you so much.
Thank you. Now I would like to invite you, our rector of Kocaeli University, Professor Mustafa Cantürk, please.
Niye burada görmüyoruz? Burada da görmemiz lazım. İşte konuşuyoruz.
Dear colleague, first of all, I would like to address to my colleagues in Turkish, if you let me. Değerli arkadaşlar, burada bulunmaktan, burada bu sunumu yapmaktan, bu toplantıyı burada düzenlemekten, biraz önce Kocaeli Üniversitesi'nin Tıp Fakültesi'nin videosunu prezente etmekten büyük memnuniyet duydum ve gurur duydum. Batı'daki örneklerimizden çok farklı olmayan bir eğitim sistemimizin olduğunu dostlarımıza gösterdik. İzninizle İngilizce olarak hitap edeceğim. It is a great pleasure for me to host you here. Last night I told you it was a great honor to organize this meeting for the name of the James. James came here in 2020 As you know, we had met in Leiden in 2019 at the first meeting, and he visited here, and we decided to make the second meeting here, but we could not realize because of pandemics. And at the end, we unfortunately lost James, but we still feel in our hearts because he was very warm man. We remember he is with this very well smiling. I sent my respect from here to James. I invited you here, and you all accepted and came here. Thank you very much for being here. First of all, I would like to say something about Kocaeli University, which I told yesterday night, but I will repeat it. And our university, founded in 1992, this is the 32nd years of our foundation. Kocaeli University has 15 different campuses. This campus is main campus, and we have 19 faculties and 15 two-year school and 4 institutions, many research laboratories and research centers. In this hospital we have 900 beds, and yearly we operate almost 45,000 cases, and we accept the almost more than 1 million patients for polyclinic cases. We also have a very large hospital area, almost more than 1,500 medical students still training in our hospital. I and my colleague very happy to see you here, and looking forward to make a more cooperation and collaboration. I want to thank my colleague, my friend Furkan, because of his efforts to organize collaboration between the Kocaeli University and Harvard Medical School. I am really appreciated him. After Furkan's scientific talk, I will make a social talk, if you let me. As you know, Anatolia is homeland of the science, and I will talk about scientific surgery, which is started in Anatolia. Do you know Julius Caesar? He made his famous word, Veni Vidi Vici, in Anatolia, in the Zile Tokat, as you see on map. And there is a famous sentences or words, phrase, as rich as Croesus. Croesus, the king of Lydia, who ruled western Anatolia from his capital city Sardis, and today we know it, the Salihli. And maybe again it's this rich and colorful background. Let us follow the evolution of medical practice from its most primitive stage to highly advanced legends gave way to history in Asia Minor, Anatolia. From ancient Egyptian, Indian, Greek, and Roman writings that they try to treat the wounds, stop hemorrhages, drain abscesses, and reduce the fractures. Arabic authors such as Abu al-Qasim al-Zahrawi influenced mostly Greek, Roman, and Persian medicine. He wrote Kitab al-Tasrif. He is known the father of operative surgery. Maybe you know the Celsus. Celsus, in his publication, De Medicina, reported the characteristic of surgeons. And he told surgeon who aims to recovery of one's health cure must take it easy and must not quit to cut enough in spite of merciless. And Guido Chauliac in Chirurgie Magna reported the characteristic of surgeons. Surgeons must be well-trained, well-skilled, talented, well-characterized, and must have a leadership characteristic. On the other hand, surgeons must not only have knowledge about the surgical principles, but also must know general medicine. There are many Turkish surgeons in Anatolia, especially Ottoman period and Selçuk and Ottoman period. One of them is Şerafettin Sabuncuoğlu. He wrote his famous book, Cerrahül Haniye. I will explain later on. At that time, Arabic and Persian was a scientific language, but he wrote it in Turkish first time. Today, in this presentation, I will start with primitive surgery in Anatolia, the scientific surgery in our era. Anatolia is the land where were pioneered both scientific and cultural perspective for civilization history. One of the science branches of Anatolian people had pioneered was medicine. Medical history in Anatolia can be divided age of antiques, Hittites, anti-Hellenistic period, and Roman and Byzantine period, and Turkish period. These orders had started before human beings and continued the history of mankind. Life with domestic animal caused contamination of some disease, so men tried to find a solution to this disease, but they did not know real cause of the disorder. In the antique age, the first humans believed that the disease were originating from supernatural factors. In this video, you are seeing some findings, archaeological findings at surgery as old as a history of mankind, wound healing, extraction of foreign bodies, amputation, trepanation, etc. had been made during the ancient time. First, they tried to treat the disorders, disease, with magic or plants as a drug, but then they applied some surgical procedures such as trepanation. Trepanation is possibly the oldest surgical procedure documented with evidence. It consisted of drilling a hole into the skull so as to expel the ailment. Excavation in Anatolia, and you see in this map, have uncovered several skulls with trepanation holes, some of which show signs of healing in the bone structure. This shows the patients nearly 8,000 years ago could survive with this critical surgery in the absence of anesthesia, in the absence of antisepsis, testifies to achievement of Neolithical age empirical medicine. But according to findings, we are talking about the empirical medicine in Anatolia, but in the archaeological findings, we also see that some cosmetic surgery had done in Anatolia during the Hittite era. One of the oldest Anatolian civilization, along with the Phrygian, Lydian, as you know, with the first money used, and the Urartus Hittites ruled central Anatolia from 16,000 to 12,000 before Christ. The medical tradition at that time were centered to deities. Disease agents included disregard and disrespect towards the gods, blasphemy, betrayal of the oath, and thirtify, and personal uncleanness, among the other things. Based on magical rituals, Hittite medicine was a supernatural system of healthcare practiced by male as well as female healers. But as you know, medical development, surgical development usually is done during the wars. It was a reality that the first development had reported during the Iliad and Troya wars. In Anatolia, there are many archaeological findings about the war surgery, but some of them moved to some European museum. For example, at the right side, you see the Achilles is doing Greek bandage and exhibited in Berlin National Museum. And the left side, you see the Achilles treated the injured Telephos. And it is also exhibited in Europe, Napoli National Museum. Unfortunately, we lost them when we want them to bring their native land. Illness came from Ishara, the goddess of Oat, while Kamuslepa was the goddess of healing and medicine. Healers made extensive use of Anatolian flora, including mandrake, poppy, gallnut, licorice, saffron, olive, something like that as a balms and ointment administered with magical incantations. Malaria and plague are known to have struck the kingdom in epidemic proportions. And also there is a temple medicine in Anatolia. According to Kibele and the Rutia surgery, there are many findings in Anatolia. For example, first transplantation surgery had done in Anatolia. Cosmos and Damian brothers were 3rd century Arabian-born twin brothers who embraced Christianity and practiced medicine and surgery without a fee. This led them to be known as the Holy Mercenaries. They reputedly cured blindness, fever, paralysis, and reportedly expelled the breast serpent. Hundreds of healing miracles are attributed to the twin saint. They are most famous for miracle of the black leg. Science started in Anatolia during the 6th century before Christ. Some philosopher from Anatolia, as we know, very famous philosopher, including Homeros, Herodotus, Thales, Pythagoras, and even Hippocrates. Thales had guessed the solar eclipse, as you know, from Milet in Anatolia, and Hippocrates, as a father of medicine, lived in the island of Kos before Christ. He rejected superstitions and emphasized the natural causes and effects, identified the epilepsy as a disease rather than the divine state, secularization of medicine outside the realm of the temple, transformation of the Aesculaps cult into the professional lodge, the practice of taking case stories prior to diagnosis, and the establishment of clinical doctrines of observation, documentation, and classification. Hippocrates' school's emphasis the philosophical concept of the four humors influenced the discipline of medicine. But Hippocrates' most lasting legacy has been his firm focus on disease as the product of environmental factors, diet, and healthy living habits. Scientific surgery, I told you, started in Anatolia. For example, the Kos, Aesculapian of Kos, is very important land. In book of Corpus Hippocraticum, Hippocrates said, life is short, art is long, opportunity is not continuous, and experience is valuable, but decision-making is difficult. These are important. And you see how wound dressing made during the Hippocratic era, and some example of wound healing and surgical treatment method of Hippocratic era. Galen was another important man of our land. Galen was the follower of the Hippocrates and born in Pergamon. We say Bergama. He studied medicine in his native city as well as Izmir in western Anatolia and Alexandria and Corinth. Antique Pergamon was like this, but some of findings unfortunately carried to Europe. But fortunately they are keeping well We are happy see them in well degree. This is the from Pergamon Museum in Berlin, the Pergamon buildings. Galen knows the Divinius Galenius because of his belief in the divine spirit. The Galenic formulation is named after him. The Galen's death has heralded the Dark Age for medicine in Europe. Galen is known the surgeon of gladiators, and Galen also pioneer of the experimental surgery and anatomy. He found and reported many anatomical landmarks, and he also used to stop bleeding with the different hemostatic methods. Asclepion in Pergamon, where Galen studied in his youth, is an exceptionally well-preserved representative of the genre. Asclepia were sanctuaries and healing temples where pre-Hippocratic mystic empiric medicine was practiced. Several Asclepia were established, and physicians met at our faith healing. The earliest destination of health tourism, these Asclepias, and regularly hosted stage and music performance as well. Many of ancient era's philosophers, physicians, I told you, lived in this land. Let us take this occasion to celebrate all the old masters who grew up in this land to influence and even shape medicine as we know and practice it today. There are many findings as a surgical instrument, and most of them reported via many publications. As you see, these are the antique periods surgical instruments. They are looking like today's modern instruments, and one of them is the arrow extraction instrument. It is found many in around Asia Minor. This is the vaginal speculum, determined find in the Ephesus in the Western Anatolia. Many objects, unfortunately, moved to other counties from Anatolia. I told you we are very sorry about it. And we are still knowing the other authors, including Oribasius. He is also from Pergamon. He has 70 books, including First Medical Encyclopedia. And Paulus Agnetia lived in between the 625 to 690. He was a surgeon and gynecologist. He is also specialized in bone and the soft tissue surgery. He prepared 7 volumes book. His books was used in many Arabic and Turkish surgeons and physicians. As academies and other institutions of higher learning grew more widespread in the West, science retraced its steps back. A new period of translation ensued, this time from Arabic into Latin. Avicenna is well-known person, had almost been prophetic when he stated, science and art won't persist where they aren't appreciated. So we have to appreciate who brings the scientific medicine until today. And now I will talk about the Turkish period, Selçuk period, and then from 11th century onwards, Anatolian Selçuk medicine is inventive blend of pre-Islamic Central Asian Turkish healing practices with the medical discipline of the Greater Selçuk Empire. One notable Selçuk contribution to the field is the concept of hospitals and hospitalization that gradually spread over the Western world. Some of the earliest public hospitals were established in Anatolia. These are called the healing houses in Turkish Darüşşifa were set up across Anatolia, including many Anatolian cities, Mardin in southeastern Anatolia, in the middle of Anatolia, Kayseri, Sivas, Divri, Konya. These are the Anatolian cities. Itinerant hospitals and health dispensing charities were also introduced by Anatolian Seljuks. The Darüşşifa, built in the early 13th century in Kayseri, in the honor of Seljuk Princess Gehver Nesibe, is one of the oldest universities in these lands. The double-headed eagle decorating the gate of Divri Darüşşifa, Divri Healing House, is another relic from the same period. Şerafettin Sabuncuoğlu, who lived in the northeast Anatolia, in Amasya, he took his discipline from another author, Burhanettin Ahmet. He was a good calligrapher. He started his journey in age of 17. He was used to Turkish language as a scientific language in his treatises. One of them is Cerrahütül Haniye, I told you, which there are many druid colored medical illustration. He prepared it at age of 83. You see this book, and there are many publications about this book and about Şerafettin Sabuncuoğlu. In this book is written we have 3 copies of this book. One in Paris Bibliothèque National Museum, and the other 2 in Turkey. In this treatise, he recommended surgical management, management of neurosurgical diseases, and he also gave solutions to possible complications after surgery in details. He demonstrated many surgical interventions, many surgical instruments, including endoscopia. As you see in this figure, he tried to use some machines and surgical methods. He suggested, for example, indirect hernia is a protrusion of cecum to the scrotum by tearing the membrane named sphincter. Also, he added that in direct hernia swelling is over inguinal ligament and there is no intestine in the scrotum. Şerafettin Sabuncuoğlu, many special interests, including proctology, and he is well-known Turkish surgeon. And Ottoman period is another period. It is continued to follow the Seljuk period. Informed consent is important foundation, important development of this era. They prepared and they wanted the patients' willingness to making something, and so first they used the informed consent at that time, and also they practiced the musical therapy. Ottoman medicine followed, I told you, the Seljuk period, and then at the end of the Ottoman period, smallpox vaccine developed, and it is carried to West by the wife of British ambassador Lady Mary Montagu, and the ethnic Latin Ottoman physician Emmanuel Timonius reported it in 1714, and this method saved untold millions of deaths and disfiguration. Another development is the nursing profession. During the Crimean War, Florence Nightingale served for British Army in this land at Üsküdar, Istanbul, for 2 years. She, as the national heroine, helped her launch the Nightingale Training School that revolutionized the concept of hospital hygiene and patient care. Another surgeon is Cemil Topuzlu. He was very famous Turkish physician. he made many contributions, including suing the vessels. His grandson also very well-known surgeon in 20th century. And Atatürk, as you know, the founder of Turkish Republic, his health policy centered on preventive medicine, tasked with rebuilding the country after decades of devastating war, and the government prioritized the eradication of epidemic diseases, ameliorating the shortage of trained healthcare professionals, driving the relief and regulations. But most important thing of that period, Turkey accepted almost 42 foreign scientists who escaped from Nazi Germany, including many well-known scientists. I will show you. This is the letter wrote Albert Einstein to Atatürk for his appreciation for accepting these scientists to Turkey to keep them safe, including Philip Schwartz, Eric Frank, Albert Ektashi, Nissen, some of them. Most learned our language. Some became Turkish citizens and choose to stay here, but they all acknowledged Anatolia as their adopted homeland, the one sanctuary that welcomed them in their darkest hour. Eric Frank said, "When I was robbed of my citizenship and left homeless, only Turkey received me with open arms. Turkey is my homeland." And at end, this is my last slide. As you know, the Gazi Yaşargil, who is the very well-known neurosurgeon, developed many surgical instruments for neurosurgery and micro neurosurgery. He created a range of innovative instruments to enable the advancement of microsurgical techniques. But his importance for this meeting told me by James. James asked me, "Do you know the Gazi Yaşargil? He's almost 100 years old." I told I know him, but I don't have any contact. And then during his visit, he asked me. I look for and I talk with the Gazi Yaşargil. James told me Gazi Yaşargil used the protein calorie restriction for some of his cases. I talked with him and he told me it is a reality. He used the protein calorie restriction for a while, but he did not report it. He told it was beneficial, but he could not make any controlled trials, so he couldn't write. I would like to say these to remember the James again. Thank you very much to listening this presentation. I would like to show how the Anatolia, being the homeland of science and scientific surgery. Thank you very much. Have a nice meeting.
Now I would like to invite again Furkan Burak for the first session. The first session will be the cardiovascular and renal interventions with dietary restrictions. Please. Seni oraya alalım. Buraya konuşmamıza kalmış.
Hocam çok teşekkür ederiz harika sunum için. Sanıyorum sorumluluğumuzu da arttırıyor bu sunumu dinledikten sonra. So I was thinking about when you listen to this kind of talks, what really happened around. It puts a lots of responsibility to all of us, of all the way from Hippocrates to Gazi Hoca. So I think we have lots of responsibilities to contribute to medicine and surgery. So hopefully we will follow their leads. And then I'm very happy to chair this session. So we have three incredible speakers in this session. And this is going to be more cardiovascular and renal interventions with dietary restriction. So we are starting with Dr. Florent Alanya. And he holds a PhD in biology from the University of Lausanne and a robust 15 years expertise in preclinical research, focusing on metabolism, diabetes, and cardiovascular diseases. And since 2017, Dr. Alanya is leading the preclinical research laboratory within the Department of Vascular Surgery at the renowned Lausanne University Hospital. So working in close collaboration with the vascular surgeons, he's responsible for the research strategy of the department and oversees the translational research activities. And his current interests lie in mouse models of vascular diseases to explore the potential benefits of dietary interventions on peripheral arterial disease and abdominal aortic aneurysm. Dr. Alanya, please.
Thank you. So first of all, I would like to thank the organizers for giving me the opportunity to present my work here today. So you all understood that we're here to talk about calorie restriction because we know that calorie restriction protects from surgical stress and age-related disease. I think Furkan made a great point of this, so I'm not going to go through this again. What we're interested in at the moment in the lab are two different dietary interventions: time-restricted eating and carbo loading. So I will kick off by talking about preclinical studies that we do in the lab with time-restricted eating. So my lab focuses mostly on models of microsurgeries in mice to model vascular diseases, and so we come with nutritional approaches to try and treat those models. So the first thing I'm going to talk about is a model of abdominal aortic aneurysm, and then I'll talk about another model where we study intima hyperplasia, which is another vascular disease. I'll get into that later. So abdominal aortic aneurysm, or AAA, is a vascular disease of the abdominal aorta. So it concerns mostly men over 65 years old, 5% of men, and it's responsible for 2 to 3% of deaths in Western countries, and it has an 80% fatality rate when ruptured. So a lot of it's hard to find. It's usually asymptomatic. So rupture is often the first sign of the disease, and there is no treatment once we find an aneurysm and it's not ruptured. There is no treatment to slow down its progression besides management of risk factors such as hypertension, smoking, and dyslipidemia. So we need new treatment to reduce our old AAA progression, and that's why we're looking at time-restricted feeding here. First of all, I would like to introduce a little bit the model that we use. So as I was saying, we do microsurgeries on mouse. So this is a mouse under the microscope. You can see the aorta here. This is the renal artery. You can see a piece of the kidney here. This is all the intestines pushed to the side here. And what we do, so we're right below the kidneys, and what we do is that we apply a Wattman paper infused with elastase, and we leave this in place for 10 minutes. The elastase is going to degrade the elastin, which is an important component of the wall of the aorta, and gives it elasticity, as the name implies. And we also treat the mice with a compound called BAPN in the drinking water, which is going to block the cross-linking of topoelastin to form again new elastic laminae in the aortic wall after digestion. And this leads to the development of infrarenal aortic aneurysm, as you can see here, this large formation. And this takes about 2 weeks. We can keep the mice up to 3-4 weeks. So how did we approach this? Trying to use time-restricted feeding for this disease. We decided to put the mice on Western diet to kind of trigger, as Furkan was saying, some kind of metabolic dysfunction, because we are talking here about young male mice. So we challenged them a little bit with the Western diet to get to this pro-inflammatory, very slightly pro-inflammatory environment. Then we performed the surgery on the mouse. We leave the mice to recover for a week, and then we put them for 2 weeks on TRF. So it's really here a post-treatment with TRF to try to slow down the progression. We don't try to act on the formation, but really the progression. I won't go into the details here of what we observed with this 2-week TRF intervention. As expected, we see that this intervention reduce body weight gain under the Western diet, and we see improvements in a lot of metabolic parameters, in the lipid profile, in glucose sensitivity, glucose tolerance. But what we're mostly interested in, of course, here is the size of the aneurysm, and here, as you can appreciate, we see a decreased max diameter of the aneurysm in mice on ETRF. So I'm talking here about ETRF. This is what we call the early TRF. It means that the mice, they had access to food during the beginning of their active phase. So the equivalent of eating during breakfast and lunch, and then they don't have food until the next night. So they basically skip dinner. We also observe, when we look at the profile, RNA profile in this aortas, that we have decreased inflammation in the aortic wall and decreased matrix remodeling. I won't go into the details of the different markers. Looking closer by histology, so these are cross-section of the aortic wall where we stain for inflammation with CD68 that stains for macrophages. You can see there is, so I'm not showing a native aorta, but you don't expect to be any macrophages or very few resident macrophages. But here, in the control situation, we have massive macrophage infiltration in the aortic wall, and accompanied by degradation of the extracellular matrix. And with the mice on ETRF, we see decreased infiltration. We can also quantify the size of the aneurysm by histology. These are the metrics here. The diameter or the lumen area of the aorta are decreased on the ETRF. The elastin degradation grade is also decreased. This is CD68 infiltration, so it's macrophage infiltration. You can see that it's decreased. And we also observe that there is decreased proliferation of those macrophages. So, like Furkan was saying, really ETRF, we fall into the anti-inflammatory effects of dietary intervention here. So I won't go more into details for this. We're still working on this, trying to understand how it works, what are really the molecular mechanisms explaining the benefits of ETRF. It could go a number of ways. Now I would like to talk a little bit about intimo hyperplasia. So first of all, I need to explain what is peripheral artery disease and critical limb threatening ischemia. So peripheral artery disease is when you have the consequence of atherosclerosis, when you get an occlusion in the limbs due to atherosclerotic plaque. This will lead to peripheral artery disease, which can progress to critical limb threatening ischemia when really there is severe occlusion of the major arteries. And this is something we see often in diabetic patients, which have also dysfunction in the microvascular department, so not only the major arteries but all the vessels. And so these patients are in need, dire need of revascularization, surgical revascularization. Unfortunately, 20 to 30% of patients are not amenable to revascularization or have failed revascularization. So although we can restore some blood flow, it's still not enough to alleviate the symptoms. And the second problem we have is that there is a high failure rate due to secondary occlusion of the vessel via a process of intimal hyperplasia. And so this is a slightly different disease than atherosclerosis. It's an abnormal response of the vessel to the revascularization, to the vascular trauma endured during the surgery that leads to the formation of this neo-intima layer, which is going to grow towards the lumen and progressively occlude the lumen. And we're trying to understand better as vascular surgeons how to slow down this process so that we can maintain vessel patency postoperatively. And so we have a mouse model to study intimal hyperplasia. It's a carotid artery stenosis surgery that was developed by Kisozaki. In this model, again, in this microsurgery, we make a ligation of the carotid artery, and the vascular trauma is going to trigger this intimal hyperplasia response. So again, here we're looking into TRF, the same kind of eTRF, to reduce intimal hyperplasia. So here, this time we took LDL receptor knockout mice. So these mice are severely hypercholesterolemic and have a tendency to form atherosclerotic plaque. And we put them again on Western diet to even further damage, further increase the dyslipidemia. And then we compare mice that were fed ad libitum on the Western diet or mice that received eTRF. So here for this model, we let the mice recover for 2 weeks post-op, and then we started 2 weeks intervention with TRF. And we were very happy to observe that the eTRF can really drastically reduce intimal hyperplasia in this model. And this is the quantifications here. And looking more into what's happening in the wall of the carotid, we see that we maintain a better media layer with the expression of MYH11. It's a marker for smooth muscle cells, for contractile smooth muscle cells. And we also see a decreased proliferation of the smooth muscle cells in the carotid wall, which is really, for us, a very good indication that we have smooth muscle cell proliferation is really the culprit in intimal hyperplasia. This is what's driving the formation of this layer, which is going to occlude the vessel. So it looks like eTRF is able specifically to stop this, or to drastically reduce the smooth muscle cell proliferation. So that's it with time-restricted eating. Using preclinical model, we show that it's lowering progression of abdominal elastic aneurysm and intimal hyperplasia, and we're working on this to try and understand the mechanism. Now I would like to switch gear, talking about carboloading. So why we're interested in carboloading, it all comes from the work of Jay working on protein restriction. And I will explain how carboloading, we think, can be a weird way of doing protein restriction. We're interested in carboloading because, as Furkan was mentioning, dietary intervention has been shown to protect against surgical stress. It's like a preconditioning for your body to, when you undergo surgery, it can have really anti-inflammatory, antioxidant effects. And actually, we don't use dietary restriction in the surgical ward. Currently, what we have access to is this ERAS program. So ERAS stands for Enhanced Recovery After Surgery. It's a brand that includes 3 arms. There is intraoperative recommendation, Post-operative, from a nutrition point of view, they recommend that we should restart oral nutrition post-surgery as soon as possible. But the interesting bit for us is that there is this preoperative carbo loading which is recommended for patients undergoing some surgeries. It's been really used in visceral surgeries for a number of years now. And this program has shown that really it shows benefits against surgical recovery, especially length of stay of patients. The patients are discharged faster, usually in the departments that use this approach. So we started to think about how to reconcile this carbo loading, which means getting more calories, which we keep saying is bad, and the fact that we as scientists were convinced that calorie restriction should be beneficial and not carbo loading. The problem with the ERAS program is that there are very few people who really try to deconstruct these three arms and just test carbo loading alone. So we don't know if really this preoperative carbo loading really brings benefits or if it's the other arms. So there is stuff to do here in terms of clinical trial to really understand if carbo loading can bring benefits. But coming from this, we started to think about what this carbo loading is doing, and we started to think about this effect that has been reported of protein dilution. So when you eat a diet, you're going to have three major components: lipids, proteins, carbs. If you reduce proteins, it has been shown that the best way to get the benefits of protein restriction is to replace the protein by carbs and not lipids. So what we were wondering is that what is really happening when you do carbo loading is that you change the nutrient balance in the patient's diet. And so instead of really doing a carbo loading, so getting more carbs, what the body is really sensing is that in proportion, the protein are reduced. So we formulate this hypothesis that we would give 50% sucrose water to the mice. So again, preclinical study. Mice on a controlled diet with normal protein content, about 19%. And we did this for 1 week before doing a surgery. So here, the model of surgical stress was renal and liver ischemia reperfusion injury. So basically what we do is that we open the mouth and we clamp, so we restrict blood flow to the organ for 20 to 30 minutes, and then we reperfuse. And this is a very well-known model of surgical injury. And so we did this. So this is with the kidney, with 23 minutes ischemia reperfusion injury on young male mice. And we saw that mice that were on the high sucrose diet, they had reduced damage. I will not go through all the details. We could also see that this works as well in female. And it works also in old mice, which is important because our patient base, they're usually not very young. And what we went on to show is that what actually happens with this diet, and we really compared this diet preconditioning to a low protein diet, and basically what we see is that when you increase the glucid content, you do decrease the protein content in the diet, because the mice, if they have access to sucrose water, they're actually going to eat less because they're going to get their calories from the sugar, and they really like the sugar. They prefer it to the actual solid food. So this was a very neat trick to really have a low protein diet while giving actually a standard diet. And this is what we can see here. Just quickly, this is the food intake of the mice that were on different sucrose water supplements. They really decreased the food intake compared to the control mice because they really increased their water intake. And this leads to a decreased protein intake and increased overall calorie intake. So we still have this carbo loading, we're still giving more calories to the animal, in this case, but the proportion of protein in the diet is severely reduced to similar levels as what we get with a 6% protein diet. Now we have this latest study where we're trying again to use this model, this diet in another surgery, which is ligation of the femoral artery to really look at the vascular repair potential in the mice. And we see that with this high sucrose diet, so this time we lowered the sucrose content because we're trying to optimize this sucrose diet. And we see that with the 25% sucrose diet, we can improve the recovery, improve the revascularization in this model, and reduce ischemic damage to the muscle. Because when we do this model, we have ischemic damage here in the muscle below. And what we've shown is that there is really a specific effect on endothelial cell proliferation in the muscle, so formation of new capillaries which are going to replace the vessels that died during the ischemic injury. And we also observed that, this I won't go into the details because it takes me too far. So our current hypothesis with this carbo loading is that it actually mimics a protein restriction. And I didn't show all the data, but our working current hypothesis is that this triggers this typical response to protein restriction in the liver, which leads to FGF21 expression. This FGF21, we're still trying to figure out whether it acts directly in the periphery. FGF21 has also been reported to act on the adipose tissue to promote the secretion of adiponectin, and in the cardiovascular system it could be that adiponectin is the culprit. And this is something we're working on very actively to try and understand how these two adipokines mediates the benefits of protein restriction, because obviously this is something we can give to patients. And so further work is ongoing. In a few minutes, I just want to brush on moving away from preclinical research and to actual clinical research. So based a little bit on the first part of the study, we also tried to do a randomized controlled trial called OptiSurge. The idea here was to do TRF pre-op to get the benefits against surgical stress. The patient population was PAD patients, front-end stage 2, undergoing open femoral endarterectomy, so it's an open reconstructive surgery. And we had two arms, the control arm and the TRF arm. The TRF consisted of 2 weeks eTRF, eating so only from 8 a.m. to 4 p.m. with, as typical for TRF, there is no advice on nutrition, quality, quantity. It's really just the time window. So you can eat whatever you want, but just during that time window, and you should be fasting the rest of the time. And it was mostly a small safety study and see if it was feasible. So it was a small number of patients, and our primary outcome was death and MACE in males, so major advanced sleep event and major advanced cardiovascular event. We followed the patients for acutely, just post-op, day 1, day 30, and up to 1 year. And so as I said, our primary endpoint was safety. We also monitored the adherence of the patients to the diet by using the smartphone application developed by Sachin Panda. We also looked at, of course, vascular endpoint as vascular surgeons, so improved in limb perfusion, ankle to toe brachial index, and of course, as I said, major events. We also looked at metabolism, weight, BMI, blood pressure, lipid levels, lipid profiles, and immunity. The goal is to look at immunity by mostly looking at pro-inflammatory markers, circulating pro-inflammatory markers. What I can say so far is that we recruited only 12 participants It was very hard to recruit. Most patients, when presented with the intervention, declined to join the study. All the people who were included completed the study. They were all actually very eager to do the study, so there is a bias there. Median age was 75 years old, sorry. In terms of safety, no adverse events, no deaths reported 1 year. So the 2-week TRF is safe for this patient. Very good adherence to my circadian clock app, to the diet, but we will see that really those patients, they wanted to do the TRF. We didn't observe any change in the circulating lipid profile or glycated hemoglobin and things like this. The inflammation, we didn't get around to do it yet. And the thing that was encouraging, but it's still low quality evidence with the low numbers that we had, is that the ankle brachial index was a bit better at 1 year in the TRF patients, so maybe a little bit of benefit in vessel patency. So as I was saying, really the limitation of this study, so this is the data taken from my circadian clock app, where patients are asked to log in their window-eating period, so each dot is when they eat. And you can see the controls in red and in blue the TRE, so time-restricted eating. And you see that at the end of the 2-week TRF, everybody did TRF, because the main problem is that you cannot blind these studies, and the patients that were randomized to the control group, they were all actually pretty disappointed that they ended up in the control groups. They all wanted to do the TRF.
Can we conclude in a minute?
Yes.
So, thank you.
Thank you. And then they return to the eating habits. So, major limitation here. So the lessons from OptiSearch is it's safe, enrollment is difficult, and huge bias because we cannot do any blind studies. And for the perspective, we're still trying to work out how to best do this carbo-loading protein restriction, maybe trying to combine it with TRF. We're looking into adiponectin and FGF21 receptor agonists, as well as metformin, because we have evidence that the MPK pathway is probably involved. And from a clinical standpoint, we're trying. We don't have ERAS in the vascular surgery department in the Lausanne University Hospital. Other surgical departments are doing ERAS. So we're looking to implement ERAS and maybe also try to do a specific randomized control trial to test just carbohydrate loading versus water alone for surgical recovery. With this, I would like to thank all the people involved and you for your attention. Thank you.
Thank you so much, Dr. It was a great presentation. So I think we can get the questions in the break, given the time restriction. And then thank you so much. And we will continue with the second presenter, Margaret de Vries. So basically, Dr. Margaret de Vries is a professor at the Department of Surgery and has a long-standing interest in vascular remodeling, from neovascularization and atherosclerosis to post-interventional remodeling in vein grafts and arteriovenous fistula using clinically relevant microsurgical in vivo models. The involvement of inflammatory factors and dietary restriction on vascular remodeling, as well as non-invasive imaging strategies, including ultrasound and photoacoustics, are her latest interests. Dr. de Vries has published over 130 scientific papers and presented her work at the international conferences and invited meetings. She's an active reviewer for funding agencies and numerous journals, and she's a co-founder of the Dutch Network on Photoacoustics and Ultrasound.
Thank you for the kind introduction, and it's an honor to be here. Thank you so much for the invitation. I'm one of the few, I think, that have been to all the workshops, and it was a major disappointment that we couldn't meet up in 2020, so it's really great to be here today. And indeed, I'm going to talk about some dietary intervention studies, but also some of our latest photoacoustic work. So one of my interests is arteriovenous remodeling, for instance, in vein graft remodeling, which takes place when you perform a bypass surgery, either coronary or peripheral. And ideally, you want to use an arterial bypass because they have better outcomes, but most often a venous bypass is used. And one of the major tricky points of venous remodeling, of a venous graft, is that it really has to adapt to the changing hemodynamics, so from the venous system to the arterial system. So this venous graft has to arterialize to get adapted to these hemodynamic changes. And with that, it has to thicken the vessel wall and get used to this pressure. If we look at the process that this vessel wall has to go through, is that in the early phase it has a lot of endothelial damage, which can lead to thrombosis, although there are a lot of drugs that can reduce this risk. But in the middle and long term, you have remodeling that's driven by an inflammatory phase, and you get proliferation and migration of smooth muscle cells, and these smooth muscle cells, but also fibroblasts, start to produce a lot of extracellular matrix. And depending on the metabolic state of this patient, especially if this patient has high cholesterol levels, you can also get a form of accelerated atherosclerosis, as you can see depicted over here. So if we look at diet and atherosclerosis in mice, but also in humans, we know that if you perform these patients or mice are triggered with a high-fat, high-cholesterol diet, you can see really an increase in lumen size. So there's a direct relationship between the diet and the vessel wall size. But what depicts this? Because as you can see over here, unrelated to the diet, the lumen size stays the same, but it's more the vessel wall thickening that depicts the worsening of the situation. So we focus on the cells that are involved in this situation, and we have performed single cell nuclear sequencing, and here you can see three of the major groups, so endothelial cells, immune cells, and smooth muscle cells and fibroblasts that really depict the fate of the vessel wall. So we also confirmed this with flow cytometry, and here we really focused on the immune cell content, and we know that most of these grafts contain macrophages and dendritic cells, but also B cells and T cells. So how does protein restriction affect these cell types? So we've performed an experiment where we fed mice a high-fat, high-cholesterol diet, and these mice were atherosclerosis prone. We used LDL receptor knockout mice for this study, and in one group we replaced the protein content with carbohydrates for only 1 week before surgery. So the hypothesis was that due to the protein restriction, we increased the cytosine gamma lyase or CGL enzyme, and that increases the hydrogen sulfide in these cells, and it's known that hydrogen sulfide has an anti-inflammatory and vasodilatory prospects. So looking at these vein grafts after 4 weeks, we really could see that we had a reduction in intermedia hyperplasia, and if we look at the smooth muscle cell content, we see a reduction in smooth muscle cells upon this protein restriction. But also, we could see effects in endothelial cells, and especially we saw an increase in CGL activity and H2S activity. And this was really CGL dependent, which is also kind of known that in the festival, CGL is the most important hydrogen sulfide producer in contrast to, for instance, CBS. But we also saw effects on immune cells. In this case, we stained for neutrophils. So this is early on in the process. So this is a vein graft after 4 days. And we see a reduction of neutrophils both in the intima, but also in the adventitia and the outer layer, the PFAT. We also performed an experiment where we used a methionine restriction, so we also only restricted in the sulfur amino acids, methionine and cysteine. So we used a diet where this was replaced by other amino acids, and we performed multiple groups, and one group of 2 groups of mice that received the methionine restriction either had PFAT around the vein graft or not, but the part on the PFAT, Thijs Sluiter will present later today, so I will only stick to the part where we discuss the vein graft itself. But if we look at these mice, and we also performed this study with only 1 week of dietary restriction, methionine restriction in this case, is that these mice, although they ate more, they had an immediate decrease in their body weight, but after replacing the methionine restriction diet with the control diet, the body weight increased again. And after 4 weeks, we indeed, especially in the PFAT containing group, we saw a reduction in intima media areas. Now, also looking at the content, we could see that in this case we saw a slight increase in smooth muscle cells in this in the intima of these methionine restricted fat mice. So we know that the smooth muscle cells are quite plastic. They can be either contractile or synthetic, and synthetic smooth muscle cells are really characterized by a proliferative, migratory, but also high content of extracellular matrix proteins. So we looked at extracellular matrix in these mice, and we stained them for a general collagen marker, but we did not see any differences in the amount of collagen in these vein grafts. Next, we looked at proliferation in these mice, but also in smooth muscle cells in culture. And surprisingly, we did not see significant effects on proliferation. And then the next step was to study migration in these smooth muscle cells. Studying migration in vivo is quite hard, so we did it on cells, the smooth muscle cells in culture, and we saw an increase in the migratory capacity up on methionine restriction. So we also looked at immune cells, and in this case the macrophages, and most macrophages have a pro-inflammatory character, characterized by interleukins 1 and 6, for instance, but also TNF-alpha, MMPs, and reactive oxygen species. So for this, we used INOS as a marker for the M1 pro-inflammatory cells and a mannose receptor for the anti-inflammatory cells. So, and we saw when we quantified the pro-inflammatory macrophages that especially in the media and adventitia, we saw a reduction in these M1 macrophages. But to our surprise, the methionine restriction diet really increased the anti-inflammatory macrophages. So if you look at the ratio, we saw in all, both the intima and the media and the adventitia, an increase in switch towards these anti-inflammatory macrophages. So to conclude briefly, So both strategies, dietary restriction and methionine restriction, beneficially influence vein graft remodeling, and we saw that we have protective effects on the endothelial cell function, moderate effects on smooth muscle cells, but we really saw an effect, an anti-inflammatory effect, either on neutrophils or a switch from a reduction of pro-inflammatory macrophages towards the anti-inflammatory macrophages. So I hope I can convince you that really the cell content determines the fate of the strategy of the dietary restriction, the methionine restriction. But how can you use this also in the clinical practice with these clinical trials? So what if we could track vessel wall composition in a minimal invasive way? And with that, we come to our photoacoustic imaging. So photoacoustic imaging is an imaging strategy most times used in combination with ultrasound imaging, and using a high-frequency sound. This causes thermoelastic expansion of tissues, and that's something you can pick up as light with the ultrasound detector. And interestingly, there are a lot of components in the body that have very specific photoacoustic spectra. And one of the most known is hemoglobin. So the hemoglobin and oxyhemoglobin, they have this very distinct spectra, but also lipids and collagen. And now we are also looking at elastin, for instance. So they have spectra both in the near 1 region, so from 600 to 900 nanometers, and in the near 2 region. So here you can see an example where we use the ultrasound imaging of the vein graft in combination with the imaging of the oxy and deoxyhemoglobin. So with this, we can really measure the oxygen content in the vessel wall itself, which can be used as a function of the endothelium. But we also performed a whole-scale spectra analysis, both in the near 1 region and the near 2 region, and compare this with ideal curves. And with that, we could really, in a non-invasive way, image the vessel wall and look at the adipose tissue in and around the wall, and also the hemoglobin. And in this case, I didn't show the collagen, but that's also something we can measure. But interestingly, you have various types of collagen, but when we looked both in vitro and ex vivo, in this case, tail of a mouse, we can see that these different types of collagen have different spectra, which is also the case for lipids. So, for instance, the brown adipose tissue has a different profile than white adipose tissue. But what about cellular types? That's difficult to image those, but we can label these with, for instance, indocyanine green, which has photoacoustic properties, and we can conjugate these to antibodies, and we can inject these, and then you get this spectrum, which is, and this is an image of the collateral of the carotid artery. And if you unmix this, you can really see these endothelial cells. So you can label all types of cells, and with that, you can really get an image of the content of a certain tissue, in this case, vascular tissues, but of course you can also use it for other specific types of tissues, and can monitor the local progression of diseases. So I hope I can convince you that also photoacoustic imaging shows a great promise for determination of tissue composition. And with that, I would like to end, and thank you, and happy to take any questions.
Thank you so much, Margaret. So we have time for a couple questions. So maybe I can start. So this is really interesting. I think it's the both for certain amino acid deficiency can mimic or give you the benefits of calorie restriction, but in a way that we think it's some sort of like a secondary benefits coming from even downstream effects.
Yeah.
So, like, is there any other amino acids we should think about taking out and try to mimic calorie restriction?
That's a very interesting question. I'm more part of the vascular biology itself and not so much the amino acids, but I know that a lot of people work on it, but not particularly different amino acids, more other forms of dietary content. I know that a lot of interest now is on more the plant-based diets and the beneficial effects of that. We know from this, the methionine restriction, the sulfuric containing amino acids, that's really hydrogen sulfide mediated. Not sure if other amino acids really have different properties.
Thank you so much.
Thank you.
And also please keep your questions at the end of the whole meeting. We have a special discussion that with the whole speakers we can discuss more in details. And the last talk of this session is from Dr. Felix Köhler from University Hospital of Cologne in Germany. So Dr. Köhler received his medical degree, being a physician degree from the medical faculty of the University of Cologne, and is trained in internal medicine and nephrology at the University Hospital of Cologne, Germany. So his research focuses on novel therapeutic approaches for acute kidney injury that examine the dietary therapies in rodent models and human clinical trials using multi-layered omics approach to identify druggable targets.
Thank you for the kind introduction. Where can I start it? It's on Turkish, so that one? Ah, okay, and then it's first one. Thank you very much. Thanks for the kind introductions, and thanks for having us here in Kocaeli. So I'm a nephrologist, and I'm working at our university hospital in Cologne. And first of all, my disclosures, I want to keep them short. So I'm studying acute kidney injury. Acute kidney injury is a really common disease, what we have in internal medicine. And we have different diseases leading to acute kidney injury, such as sepsis, as acute decompensated heart failure, cardiac surgery, or, for example, nephrotoxic drugs. And AKI is a really common disease. So we define acute kidney injury due to the KDIGO criteria, and we know that they have an overall prevalence among all medical subjects in hospitals, roughly about 20%. And the KDIGO criteria has 3 stages. So stage 1 to stage 3, and as you can imagine, stage 3 is the most severe form of AKI, needing dialysis. And so we do have a high prevalence of AKI in hospital, and we have also high prevalence of dialysis-dependent AKI in our patient cohorts. And the other way around, AKI is also a very deadly disease. So mortality is ranging about 20% in our patient cohort. And the problem we're facing is that we don't have any, causal therapeutic approaches at hand. What we can perform is our supportive measures like dialysis. We can monitor fluid balance, use diuretics, for example, if needed. But we don't have, a causal therapeutic approach at hand. And now, having heard lots about different forms of dietary intervention and caloric restrictions, and James' work back in 2010, this got us thinking and using, like dietary preconditioning strategies to prevent AKI happens. So, first of all, I would like to briefly introduce to our most used model. We have different models of AKI. We mostly use an renal ischemia reperfusion injury model, where we remove the right kidney and clamp the left kidney vessels for 40 minutes. And now we use this model in terms of different dietary interventions. So we tested there all in parallel because we wanted to come up with kind of a systematic analysis. So what we have is obviously the negative controls, the non-PC animals, then sham animals are another control where we just performed right nephrectomy without clamping of the left kidney vessels, and those mice do not develop any AKI. From James' work, we know that caloric restriction does protect from AKI, but we do have the problems that we can't translate caloric restrictions so easily to our frail patient cohorts in the clinic. And so we use different, more of tailored dietary approaching, including a fasting mimicking diet, two dietary interventions, either fully restricting methionine and cysteine or restricting them by 80%. We use a ketogenic diet and obviously a dietary restriction of branched chain amino acids due to the fact that they are known to inhibit mTOR in this way. And what was really impressive is here in gray, this is just the survival curve of the non-PC animals. So roughly about 50% of the animals die due to our renal RI procedures we perform. And up here, our diets are really beneficial, namely obviously caloric restriction, but also the fasting mimicking diets. And both diets either fully restricting, fully depleting or restricting sulfur-containing amino acids by 80%. The ketogenic diet kind of had moderate benefits effects, whereas the BCA diet really failed in protecting. And coming from nephrology, we always want to quantify kidney function. And here, therefore, we use creatinine and urea. And here again in gray, this is the negative control, the non-PC animals. So we have a severe impaired kidney function in those animals in terms of creatinine and urea values, whereas with regard to our beneficial diets, we see a normal or near to normal kidney function. And having this impressive result, we went to the clinical trial center and set up a pilot clinical trial. And this is the so-called DICA trial, which is currently performed as a single center investigator-initiated trial that we perform together with our transplant surgeons, but we want to precondition the kidney donors in the setting of living kidney donation. And we have two aims we want to follow. First of all, this is a biobanking trial. So I can stress out, we obtain now human samples of the so-called pre-transplant kidney biopsy core, of renal vessels, and of the perirenal fat. And on the other hand, it's also, a pilot trial which we're looking into feasibility of these different dietary interventions. So we rather keep them short. We do the prolonged diet for 5 days, and a ketogenic diet, and a sulfur-containing amino acid deficient diet, or control diet for either 7 days. And for those 3 diets, we are managing to do, these are basically formula diets which the patients get, enabling us in the down the road and a double-blinded clinical trial with, having the best diet here, which we can safely manage to give our patients. And as I said before, it's also a biobanking trial because we need to know and to reveal the underlying mechanisms of those mediated renal stress resistance. And I want to focus now my talk on the one hand side on the transferation pathways, so HRS, like Margaret did, and on the other hand, I want to focus a little bit on gut microbiota remodeling. The kidney is a really complex organ. We have known to have roughly about between 60 or 70 already identified cell types in the kidney. And AKI plays really damages the so-called S3 segment of the proximal tubulus. Due to the fact that here we have a high energy demand. You know, we have to extract amino acids, sugars, etc. from the urine, get it back to the blood. And on the other hand, we have a low oxygen gradient. And those cells are the primarily affected cells by acute kidney injury. And we then use single nucleus RNA-seq to come to the point of what's happening in the cell types. And here you see just our UMAP, and we use marker genes to annotate all different cell types in the kidney, and we were able to annotate these so-called S3 segments of the proximal tubules. And the first thing we did then was just performing, you know, like a biological processes analysis in an unsupervised manner, now in, you know, on a cellular specific level. And what's plopping up, these are just the top 20 processes which are commonly, you know, like regulated by calorie restriction and by the diet restricted or fully depleted by methionine and cysteine. And what, you know, like is an overlapping change biological processes in these cell types are sulfur compound metabolic processes. And looking downwards was basically our methionine and cysteine catabolism, which has been differently regulated. And on a gene level, we saw that we had a strong upregulation of oxidative cysteine catabolism, mainly of CDO1, causing sulfide production, and on the other hand, we have the so-called H2S branches, mainly via CTH, and here this is a proteome also via MPST levels. Whereas we also saw that they have kind of a downregulation of pathways leading, you know, like away from this cysteine catabolism, like towards taurine, this so-called CSAS pathway was downregulated, as well as CBS was downregulated. And next, what we did is we just used targeted metabolomics and quantified, on the one hand side, sulfide, and then the other hand side, sulfocysteine, which is a direct readout for sulfide. And what we could see is that all of our beneficial diets commonly changed sulfide production and causing really an increase in sulfide. And this is also the case when we look into patients again. So those patients underwent a low SAA diet, and also they have increased levels of sulfocysteine. And this now, and this is the current project we're working on, we are going into cysteine catabolism by using knockout mice on the one hand side with those target genes, and on the other hand we can use drugs. We have drugs there which mimic the effect of calorie restriction of SR100, and those drugs either increase CDO1, just like cholestyramine, or they increase MPST, like sulfonylurea, an ACE inhibitor, and CTH, which is increased by tadalafil. And this is really important for us because all of these drugs are EMA-approved, so having our kind of translational research approach in mind, we want to now test them again in mice and see whether they also have the same protective effects compared to our diets. For the second part of my talk, I want to give a short introduction about our recent insights into microbiomics, because we collected from all of these dietary fat animals stool samples after diet and after renal ischemia reperfusion injuries at various time points. And what we could see is that our beneficial dietary interventions commonly changed the microbiome diversity. So we have here the alpha diversity using the Shannon index on the left-hand side, and on the right-hand side in the middle, this is Bray-Curtis, beta diversity. And what we could see is that we have, due to our beneficial dietary interventions, an ROI-dependent change in microbiome diversity. And looking more now on a film level, we see that they commonly change here the bacteroides to firmicutes ratio, both SR100 and also caloric restriction. And we know this change in bacteroides to firmicutes from longevity trials with caloric restricted mice. And there, the first we look into this after 6 months of caloric restriction, we saw this change after just 2 weeks of our dietary interventions. And what's really impressive is that they perform this in RI-dependent manner. And looking down now on the species level, this was out here in green based on an enrichment in Lachnumsparaceae in our beneficial diets. And Lachnumsparaceae are known for their short fatty acid production. So they're producers of acetate, butyrate, and propionate, and in renal metabolism, the TCA is really important as a kind of to be resist against stress. And what we could see is that we have an increase in acetate, butyrate, and propionate, and the kidney, here we use bulk omics, transcriptomics, was changed by caloric restriction by the means that the enzymes allowing the entrance of these short fatty acids into the TCA were upregulated by caloric restriction. So we have kind of the combined thing happening. On the one hand side, the microbiome is changing. On the other hand side, we see even that these changes, this production is reaching the kidney. And this is for us now in nephrology, the microbiome is getting really interesting, and just yet another target which we can also, get to via diets, but also thinking about anti-infective therapies. There are drugs out there where we can mimic our effects. And with this, I'm happy to answer any questions, and I'm thanking for hearing to me.
Thank you so much. I think it was a great presentation. Any question from the audience? And maybe I can start again. So this is really, really interesting. I think also really changing field in the gut microbiome that all of us in every aspect of medicine, we are talking about it. And everybody wonders how we can change things. And caloric restriction is one, but if it's not possible, as you know, currently there are microbiome changing treatments, fecal transplants, and there's also an oral formulation. It's recently approved for C. diff, and they are using spores rather than the actual things. Do you think you really need that bacteria, or do you need the bacterial products to change the hydrogen sulfide, or can we use these capsules? I mean, it's almost like a pill, oral, to change for the injury.
This is a very good question. Honestly, I don't know. That's why we are currently performing an experiment where we use fecal microbiota transplantation of our dietary preconditioned stool samples in mice, but we also using tailored anti-infective treatments to change the microbiodiversity. Speaking about ampicillin, like metronidazole, like vancomycin, those are all EMA-approved, frequently used drugs, which we maybe have the opportunity to be reused. And there has been a really nice recent paper out in Kidney International where they have shown that ampicillin treatment can really help us stopping the AKI, so acute kidney injury, to chronic kidney disease transition. So for nephrology, the microbiome is getting a new target which we have to study and to invest our time in, but obviously there's much to follow which will come. Yes, please.
So all the different diets, which are very conditionally restricted, do they have a similar effect on the microbiome? And if they did, was that a surprise to you? Was that a surprise to me?
So the main effect, I can just open the Teneri plots here. So the main effects were commonly by SR100 and by caloric restriction, meaning these were our most protective dietary interventions. Regarding our fast mimicking diet, those animals again were for 3 days on the normal standard chow, and then we did not see all of these changes anymore because they've changed their chow. Regarding the BCA, we did not perform any shotgun metabolomics. So I don't know, but we just went and looked into the overlapping response of the beneficial dietary interventions. And here we see that obviously the most potent forms do or have the same microbial response. And this is quite cool for us. Yes, please?
I have a question regarding the rationale for testing ketogenic diet as a recommendation.
Yeah.
Is this simply related to the possibility to reduce protein content, or also parallel to modulate specific fatty acids in the diet?
No, it was mainly due to the fact that, you know, when we perform our caloric-restricted diets in mice, we just simply hand in, you know, like 3 grams of food, like 66% reduction in the early hours. And then the animals starve afterwards until the next day. And so obviously they will be ketogenic at a certain time point. And this was the rationale for us to perform a ketogenic diet. And ketogenic diets are getting from other, you know, like nephrology diseases like ADPKD much more familiar with us. And so in our models, they were not, you know, as protective as, you know, like FMD or the S100 diet, but at least they still had like a little effect here. When you look down here, it seems like they're separated into 2 different groups, our animals here, like each dot is 1 animal being operated. And I assume that we did not look much more into it, but I think we used an 80% ketogenic diet, so really high-fat diet, and was not as protective as like caloric restricted. Right.
Thank you so much. So
Okay.
we passed our time already. Thank you so much for all the speakers for the great talk and audience. So we are going to connect back in 15 minutes sharp. Thank you so much.